Hello, I'm Xiaoli, Metadata Librarian at Georgia's Master's Library. I'm so happy to be here presenting about our work on adapting pre-coordinated subject headings for digital collections. This is me. I do a lot of things related to digital collection metadata at the University of Florida. Here is a rundown of the agenda. I will first define pre-coordinated subject headings and then talk about facets and related issues in digital collections. Then I will share how we resolve these subject heading issues in the University of Florida digital collection that is also UFDC. Last, I will introduce a couple of topics to expand the discussion a little bit. Pre-coordinated subject headings. These headings combine elements into one heading following the order of topic, place, chronology, and form. It anticipates the search on the compound heading, which means it's a long string formed by terms from topic, place, chronology, and form. This syntax helps to provide the context or specificity for organizing the content by subjects. Why pre-coordinated subject headings could cause issues in digital collections? Let's have a close look at it. It's because one of the popular features in a lot, or if not all, digital collections, that is a faceted search. This feature uses facets to help users to group further the search result. Facets usually appear as clickable labels at convenient locations on web pages. And the pre-coordinated headings come into the digital collections, they become facets. On top of that, digital collections are aggregated environments. They were created so content can be online and can be discovered. Metadata is gathered from a variety of schemas. Terms from most controlled vocabularies are single words or phrases. The compound long string produced by pre-coordinated syntax look out of place on the facet panel, as you can see from this screenshot. Furthermore, as a study using the Digital Public Library of America data, Snapshot has proved that pre-coordinated terms have negative impacts on the interconnectiveness of records in aggregated environments. So this study used DPLA, Digital Public Library of America's data. And in this study, the researchers just broke the long strings into individual facets. And then afterwards, they did some data analysis and they introduced this concept, average degree. So the average degree is the average number of other records found by clicking on any subjects. So the study breaks these terms. And after breaking these terms, they found that this average degree actually increased, which means the interconnectiveness of records improved after breaking these terms. So the issue caused by those long strings of subjects have been discussed for decades. And OCLC's faceted application of subject terminology, FAST, is one of the solutions provided there. FAST breaks up the basic components category of topic, place, chronology, and form into separate FAST headings. And also beyond that, FAST has other facets like personal names, corporate names, titles as subject, and meeting names and events. However, FAST encounters challenges when parsing library congress subject headings, LCSH, strings into individual components. Some concepts just cannot be expressed fully using one facet. We'll come back to this notion again, like some concepts just cannot be expressed fully using one facet. Okay, let's look at how we try to resolve this problem in UFDC. Some background about UFDC. UFDC gathers content from all schools at the University of Florida, or departments of university libraries all over the Florida and around the world. UFDC hosts 1 million items from all disciplines, so UFDC is really not small. The effectiveness of the UFDC facet value vary from collection to collection depending on whether the contributed metadata has undergone vocabulary control during or after the ingestion. And also the facet values are selected from many sources, from local lists to Getty Art and Architecture Thesaurus, FAST to LCSH, and many more. This diagram shows the 4 possible routes to get data into FSOBAC, that is the back end of the UFDC. It is a homegrown system. This DAF file route takes in most of UFDC content, and it is a route for converting MARC records. However, it cannot take in values from uniform titles, publisher, some subjects, and a few more. The mapping between MARC and the underlying UFDC scheme, mostly math and math, has issues too, but it is embedded in the process and this map is not available for any adjustment. In other words, the whole DAF file ingestion is like a black box, producing unsatisfactory results. On the contrary, this route, tab limited file route, will have its own issues. It provides the precious opportunity to reorganize, dedupe, and clean up the data before importing them to UFDC. And that's where we see we can do something to resolve this pre-coordinated subject heading issue. And also, I should be clear, we didn't mean to just resolve the pre-coordinated subject heading issue. That issue alone probably won't be impelled enough for us to really like adding extra steps to do the work. It's because like that issue is on top of other issues we already have. That's why you're going to see the new method in the next slide. So what happened on this slide is we still export data from OCLC here, and then we send them through MarcEdit where we select the fields wanted for UFDC. After that, in OpenRefine, we cleaned up, reorganized, deduped the data. Finally, in Excel, we did the last runs of record by record review and further clean up before we add the info to UFDC. Returning our attention to pre-coordinate subject strings. Instead of blind dividing the long strings into individual terms, we focused on pulling out fast terms. Fast IDs are usually in the OCLC records. And we use those IDs to pull out the terms from fast directly using OpenRefine functions. This process does not only give us individual terms, but also update the data with the most current fast display values. So this whole process actually empowered us. We did what we should do, which is clean up the data before we get the data into the system. We have to say, even this process empowered us, provide the opportunity for us to improve the data quality before we get the data into the system. It is a slower process compared to DAFI, because the DAFI process is very fast. You just export the data from OCLC connection, then import it into UFDC within minutes. Voila, everything done. While, of course, it has value issue, it has many issues. However, this new process, as I said, it empowered us. Though we did have introduced other issues, minor, like OpenRefine mysteries as I put there, and we do realize there are many subject from other sources. And for those subject terms, we had to do manual work. And we do a lot of DDoP, and we haven't even get a time to think about what do we do for legacy data. After doing so much work, especially DDoP, we couldn't help to think about why it looks like in OCLC records we honor redundancy. For instance, the YAML information could capture as a part of a long string subject, and it could be captured again in 6055. So that's just one instance. There's other fields. You can see the redundancy too. Another thing we're thinking about is, can legacy metadata work be part of regular database cleanup? As usually only IT people or dedicated database admins can access database. So we understand database is essential. It needs some type of security. But can we closely collaborating with IT team to get our requesting instead of just using the limited tools provided to like from a user? So that's another thought I want to put out there. Here is the reference titles I mentioned in the talk. And if you want to know more about our work, here's a published paper. Thank you.